So last question on this test. You're given this graph, a scatter plot, and you're also shown on that the least square regression line. Now, typically, we've been finding this line ourselves by entering the data. We could enter. Oops, I don't need this. Entering these values in Desmos, perhaps entering the x values and the y values, and then asking it to generate the least square regression line. Or we figured out recently that we can use our classroom calculators to do that relatively easily too. In both cases, either Desmos or our calculators give us the slope, right? They give us this parameter, and they also give us the y-intercept. And once we know the slope and y-intercept, we have a model, right? All of a sudden, this line becomes a model that attempts to describe what's happening with the data, and it can be used for making predictions. Now, the model is not perfect, right? Because you can see that it's hitting very few of the points actually in our data set. But what's important to note is that some of the points they're actually above what the model says. And those ones that are above what the model says, right? The model is under predicting what should happen because the actual points are slightly higher than that. So when the model's under predicting, we say that the residuals there are positive residuals here. So every single one of these points has some positive residuals, and the residuals are just those distances between what the model says and the actual data point, right? In fact, we talk about this all the time. The residuals are equal to the actual value minus what's predicted. The actuals being the y coordinates for each of these points, and what's predicted is what my model gives me. Three of the points that we have here have negative residuals, right? This point, and this point all have residuals that are below the line, so they have negative residuals. So if I look at the first two questions, are how many of the data points have negative residuals? Well, it's a pretty straightforward answer. There are 4 of them, right? Exactly 4 of those data points. Let me write this up here. 4 of those data points, not negative. 3 of them have negative residuals. 3 of them are below the line. So 3 of those points have negative residuals, and 4 of them live above the line. 4 of them I highlighted with the yellowish orange or whatever. They have positive residuals. Next, C says, find the residual for the point A, and that's one of the points up here. Oh, they told me it. Here's this point A. And I know something about point A. I know that its x value is exactly 1. Right? I know that x is 1 for that point. And I know that for this point, its y value is 1.8. 1.8, right? So the actual y value is 1.8. And I can also see that point reflected in the data table. It's the first point right here, right? When x is 1, y was 1.8. Well, if I'm asked to figure out what the residual is, and I know the actual value was 1.8, what I need to do is figure out what's predicted, what the predicted value is. And to calculate the predicted value, I'm just coming up to my model, and I'm saying, okay, model, do your job. You make predictions about what y should be. Here comes the number 1 into the model, and that's pretty straightforward. I can do that, right? 1 times 1.07 is 1.07. And then if I take 1.07 and I add 1.9, I get exactly 2.97, right? So when x is 1, when x equals 1, y equals 2.97. 2.97. So this is the predicted value of y. This is what the model says y should be. And for this particular value, you can see, well, it wasn't that. It was 1.8. So I'm going to take the actual value. This is the actual value. And I'm going to subtract from that the predicted value, which is 2.97. And I get for this point, the residual is 1.8 minus 2.97, which is negative 1.17, negative 1.17. And that goes with what we believe, right? Because we can see that point A clearly has a negative residual, right? It's below the point here, so it's negative, and the length of that is actually 1.17 units. So my model says, you're going to get 2.97 the point in my data set said I got 1.8. There's a residual there, and the residual is 1.17. All right, the other thing, I'm asked to do this twice, right? And I don't know why I did this when I wrote the test. But the other one says, hey, find the residual for this point where x is 3 and y is 6. So you can see that point, it lives here, right? I know that this is my actual value of y again. It's the one that lives in my data table. And I can see the x value is 3, right? So when x is 3, I've got this actual value. So we're talking about this one, right? We know that the residual is going to be equal to the actual value, which I believe is 6, right? B has a value of 6. Yep, and then we have to subtract from that the predicted value. All right, so the predicted value we can find because we know what the x value is for that point. X is 3. So what I do is I come over to my model. The model attempts to make predictions, right? And it says, hey, I say, hey, model, I gave you 1 before, but I changed my mind. I want to give you the number 3. Can you please tell me what you think y should be when I give you a 3? So I'm going to take the 1.07, and I'm going to multiply that by 3, and I get the number of 3.21, and I'm going to add to that 1.9. So when I do that, I get 5.11. So the model says, okay, if you have an x value of 3, I predict you should get 5.11. Did I contextualize this at all? No. It doesn't have any setting. That's so sad. These are just pure numbers. I don't know. It's not cars and miles per gallon or weight or anything. Okay. So I know the predicted value is 5.11. So I come back over here, and if I'm trying to find the residual, I've got the actual value of 6. I'm going to subtract from that the predicted value of 5.11. And yes, when I take 6 and I go minus 5.11, it gives me 0.89, which is a positive value, which makes sense because I can clearly see that this point is clearly above, right, the model. It's above the model. The model's under predicting, so the residual is positive. And I'll just write that down here. This answer is 0.89. Oh, and I didn't write the other one down. This was negative 1.17. So again, you could see if you're asked to find a residual, we're just plugging in what we know and figuring out what we don't know. We knew the actual values of y for some given x's, and we used the model to figure out the predicted values of y. Last question on the test says, hey, Richard thinks that the correlation coefficient R for the data is 2.5. Explain why you know Richard is incorrect. And then it says, give an estimate for what you think the correlation coefficient is. Hey, Richard. Nice guy. I like you, Richard. You make great coffee. No, I don't know where I know Richard. Do I know Richard? I don't think I know Richard. Anyways, here's why Richard's wrong, right? A correlation coefficient tells me, it talks about the strength of a relationship, a linear relationship in this case. And correlation coefficients can just range between two numbers, right? The smallest a correlation coefficient could be is -1, and the largest it could be would be +1. And if I have a correlation coefficient of -1, what that means is that on my relationship, when I look at it, all of my data is perfectly on my line of best fit. They're all on the line exactly, and there's a negative association, right? As x increases, y is decreasing. And in the case that I've got a positive correlation coefficient, all of my points are exactly on the line, right? And in this case, I could have a correlation coefficient of 1. Well, I can see, first of all, it is going to be positive. Good job, Richard. You said positive 2.5. Clearly, this correlation coefficient is positive. But the biggest it could be is 1, but it's not 1 because I can see that these points they're not all perfectly on the line. So I have no idea, but I think good ranges or estimates would be something like, maybe, it's R is probably between, I don't know, 0.75 and 0.9. Right? I would say that it's a strong association for these two variables, so it's somewhere in there. And then I would just say also correlation coefficients can't be larger than 1. Right. So just in a response to this first part, Richard, hey, Richard, correlation coefficients can't be larger than 1. And then you might mention that they're in this range. All right, class, that's it. Thank you much. Talk to you in class soon.